Good morning, algebra class. Today we are talking about logarithms, and before we start really getting into what a logarithm is, I want to talk to you about something that you're already familiar with, which is an exponential function. So you have y equals 2 to the x. Y equals 2 to the x is an exponential function. You've already been working with these, and we usually see them in the format y equals ab to the x power. We're going to stick with just this y equals 2x for now. One of the things that we've talked about in the past, and it's become very useful for us, are inverse functions. And an inverse function, if you remember, is when we take this function and we swap out the x and the y, and then we solve for y to find the inverse of y equals 2 to the x. And maybe you can see a problem already. I have a y as a power, and I have no method of getting that y out of the exponent. And that's why we need a logarithm. We need logarithms to basically undo an exponential function, very much like x squared. And I'm going to write that down so you can see it. I'm going to write it over here though. Very much the way that x squared, and so y equals x squared, and y equals the square root of x, are inverse functions. They are inverses of one another. We need something that is the inverse of this logarithm. So coming back over here, this really is just a side note, we are going to define our logarithm this way. And then we're going to practice converting back and forth a little bit. A log, we usually use, we typically use log for log, and we're not talking about what you find in the woods, okay? A log has a base number, okay, which is also called the argument. We're going to call it the base for our purposes so that it's a little bit easier for us to understand. And I'm going to write this out in blue. I have log base 2 of y equals x. These two statements are equivalent statements. In other words, y equals 2x, 2 to the x power, means the same thing as log base 2 of y equals x. Now, when I was talking to you about inverses, I wrote this in a separate color because if I swapped out the x and the y, they're now not the same statement, are they? So I'm going to create a statement that's the same as the pink one, but in a log base 2 of x equals y. And I don't know if you see the pattern there or not. The pattern here is that the base number of our exponent and the base of our log are the same number, okay? And that brings us to a method that makes it real easy to do. If I have, I'm going to do this a different way. Use numbers. I'm going to use some numbers. 16 equals 4 squared, okay? And I want to convert that into a logarithm. Now I know 16 equals 4 squared. I know that. But we're just practicing converting back and forth to logs. So what will the base of my log be? Well, it's going to be 4 because the base of my exponent is 4. Log base 4. We always start by writing the log, okay? It is base 4, okay? And I'm going to start there. Actually, I'm going to use a different color here. I'm going to start always with the base, and then I'm going to go across the equal sign and pick up that 16. log base 4 of 16 equals, I'm going to come across from that 16 and I'm going to pick up that 2. And if you think about what a log is, it's really saying what number whose base is 4 and whose power is 2 equals 16. Now, of course, we're not always going to be using actual numbers. We'll have things that look more like this with variables in it, and you'll see why it's really useful to have these inverse functions after we start needing to solve some equations with them. Let's do another one. Let's this time put in something, let's put in a variable. So let's say 2 to what power equals, let me think of something here, 32. We're not going to solve it, by the way. I just want you to convert it at this point. So I want to make an equivalent statement, but in a log, okay? In a log, 2 is my base, log base 2, okay? Remember, I start there, I come across that equal sign, and I pick up the 32. And then I come across the equal sign again, and I pick up that x. So it equals x. So when you're converting, always start with the base of your exponent, that is the base of your log. Come across the equal sign, pick up that number on the other side, go across and pick up the number on your exponent, and that's what that's equal to. Let's do one more. We can use variables again. And again, you know what this is. You know the answer is 4 here. And in this case, because the exponent is 2, we can undo this with a square root. But that's not the point. We want to convert this to a logarithm so we can see the equivalent function, and we get a little bit of practice using a variable down here, which you won't see often, but I want you to at least see that that can happen sometimes. So we have log base x. Remember, we always start with the base of our exponent, which is x. Come across the equal sign and pick up that 16 equals, again, we're going to come across that equal sign again and pick up that 2. Okay? If you think about jumping across that equal sign to pick up those numbers and always starting with the base, you cannot make a mistake with this. So those are your examples. I'm going to do one more just because I think we might have a few in your homework that may look like this. If you have something like that, okay, again, log base x, come across the equal sign of 7 equals y. Okay. One last thing that you might want to know, and we'll start learning this now, is that there are 2 kinds of logs on your calculator. Okay, one of them is log base 10, and one of them is log base e. And those are 2 special logs that we use when we're solving equations, and you'll see them a lot. Log base 10 is the most common. This one is called the natural log, and we don't write that 10. So if you see log of x with no base number there, you know that base number is a 10. Okay, so if nothing is written there, then it is base 10. So it's written like this. It means this. Log base e of x is not written this way either. It is ln. It is called the natural log. I'm sorry, the one up here I think I said wrong. This is a common log. This is a natural log, which I said backwards. Okay, so you will see it on your calculator like this. That's what it means. It means log base e. We have talked about e before, but we will be talking about it more in the future. And right now it's just the only important thing is to know that they are written differently, and that's what the bases are of those logs. And if you have any questions, let me know, and I'll see you soon.